Next, we come to atmospheric layers. Hello there! In this video, we'll be discussing on the atmospheric layers. Now, just like the onion, let me use this analogy here. The atmosphere has many layers, like layer cake, kueh lapis, right? And these layers has different properties which differentiates themselves from each other. Now, the atmosphere can be divided into 4 layers, going from the lowest to the highest. The layers are your troposphere, stratosphere, mesosphere, thermosphere, and of course, outer space, your exosphere. Now let's take a look at this graph here. The vertical axis on the right shows the pressure decreasing with height. Yes, the atmospheric pressure decreases exponentially with the height. And if you take a look at the temperature, it actually varies differently from the different layers of the atmosphere. This actually gives rise to the differentiation between the layers of the atmosphere. Now the regions of the stable temperature marks the end of the layers below it. See the stable temperature here? So this is where the transition between the layers take place, right? Between the thermosphere, right, at the mesosphere. So we go to mesopause, mesosphere, stratosphere, right? Stratosphere, troposphere, this is tropopause. Now we can calculate the pressure of the atmosphere of a height above the sea level using this barometric formula. Now this formula only works if you take a few assumptions, right? Like all other formulas, assumptions. Always check whether your assumptions holds. First, we assume that the atmosphere is isothermal, which means that the temperature is the same throughout the atmosphere. Now second, we assume that the atmosphere behaves like an ideal gas. That's the formula. Now if in some parts of this module I will test you, I'll provide you with the formula, so please don't memorize formula. I don't believe in memorizing formulas. Know how to apply them, given the SI units here, and trying to predict. Now we can use this barometric formula to calculate the density at the height above sea level. Now if we manipulate the ideal gas equation, right, PV equals nRT, we can see that the density is directly proportional to its pressure as molecular mass. The gas constant and the temperature is constant. Now therefore we can just substitute pressure with density, right, from the barometric formula, right? Do a simple substitution. You make density the subject, which is mass over volume, and then you substitute using ideal gas here, then you can see this proportionality. Now the two assumptions taken while modeling this atmospheric pressure with the barometric formula is the biggest downfall. Why is that so? Because the temperature of the atmosphere is not constant throughout. In fact, the different layers of the atmosphere has its own unique temperature variations. You see that, right? And also the atmosphere is not an ideal gas. That's why the assumption doesn't hold. Now because of these assumptions, the barometric formula is only good as an approximation of the pressure for a certain range of altitudes. Altitudes means a different height from the Earth's surface. Now the first range is from 0 to 6 kilometers in the troposphere. The next is 10 to 20th kilometers in the stratosphere, if we take the temperature to be 217 Kelvin. Now let's take a closer look at the atmosphere just above the ground, which we call the troposphere. Now the troposphere is located between 0 to 10 or 11 km above sea level. Now this is where the most of the weather phenomenon occurs. Now at the troposphere, the temperature decreases as the altitude increases. And the main source of heat, right, at this layer is from the Earth's surface instead from the sun, because we are much closer to the solid surface of Earth than the sun, right? So that keeps us a little bit warm. Now therefore, the troposphere is the hottest at the bottom and the coolest at the top. And therefore, when you fly the plane next time, right, you see on the screen panel on the plane, they always says the temperature outside is negative something degrees Celsius, right? It's like, whoa, the sky is so cool, right? Because you have got emission of heat from the ground surface. So when we are on ground level, we are a bit warmer than up the sky. The troposphere ends, and then and high up, and then region of the stable low temperature known as the tropopause, right? Remember the part where the temperature remains constant, and then above the tropopause is your stratosphere. Now above the troposphere is your stratosphere, and this is the region where the atmosphere is the ozone layer can be found. right? So the stratosphere is located between the 11 km to 50 km above sea level, and at the stratosphere, the temperature increases with altitude. So it's the opposite, right? We go up higher, it will become hotter. Now, because the source of heat in this layer is from the absorption of the UV radiations by the ozone and the oxygen gas. Remember where you see the oxygen gas coming from? The Chapman cycle. Now, this region of the highest temperature is at the top of the stratosphere, where most of the UV radiation is filtered off. This region is the stratopause, and the stratosphere is the highest layer that can be accessed by jet-powered aircraft, right? So if you want to go any higher, we need a rocket-powered aircraft to do so. Even your F-16s can't go up higher. Now, the next layer on top of it is the mesosphere. Now, the mesosphere is at 50 to 85 km of sea level. Now, in this region, the density of the gas is low, as there are less gas above to compress and make it compact. Now, that reduces the absorption of UV radiation. Now, the temperature will drop with increasing altitude in the mesosphere as the rate of heating decreases with height. The mesosphere ends at the mesopause, right? The region with, again, no change in temperature, but low temperature now. Now, the noctilucent clouds can be found just above the mesosphere. These are the highest clouds in the atmosphere, and they're visible to the naked eye during sunrise and sunset. The highest layer of the atmosphere now is called the thermosphere. The thermosphere is located between 85 to 500 km above the sea level, and in this region, the gas is very low concentration. This is also a region where you have a high UV photon flux. The temperature increases with altitude because there's a higher UV photon flux when we go up. Now, the temperature in this thermosphere can go up to an extreme 2.5 thousand degrees Celsius. Nobody can survive if we are just out there without any protection. But the cool thing is, even with the extreme high temperature of the gas in the thermosphere, it will not feel hot to the human, as the density of the gas is too low to conduct any significant heat to the skin. Instead, we still die if you go up there, because we get fried by the radiation, UV radiation from the sun. And here are the citations for this subtopic.